Hi, I'm Jason Ross, and I'd like to invite you to join me this summer in a series of classes, discussions, reading groups on the theme of the Lyndon LaRouche view of human creativity from the standpoint of history's greatest scientific geniuses and their discoveries. In this series, we will travel along a narrow path of some of history's greatest thinkers. You can sign up by going to the bottom of this page, or by looking at the link in the video description, or at larouche.info/science. So what's going to happen with this series? The first 5 are going to bring some of the key concepts of Socrates via the writings of Plato, of Kepler, the first modern scientist, of the underappreciated Pierre de Fermat, who showed that intention is a scientifically meaningful concept, the wild genius Gottfried Leibniz, who made cause primary in our understanding of the physical world, and the great and sometimes unapproachable Carl Gauss. Then we'll pull all of this together in the 6th session to apply what we've learned from how these thinkers advanced upon the hypotheses of the past. We'll apply that to some of the issues of our modern times. For example, what is the relationship between AI, artificial intelligence, or machine learning, and human intelligence? What is the similarities, what are the differences between what a computer does when it's learning versus what we do when we're making a discovery or sharing it with someone else? The sessions are going to be second half of July and August. The exact dates and times will be determined based on the results of a survey that I will send out to everyone who registers. So if you'd like to weigh in on when these will be, sign up. At least one of the times, I might do these twice each week, will be available for people in Europe for sure. So please don't worry about the time zone issue if you're in that sort of time zone in the world. And with that, let me leave you, if you want some more information about these, with the talk that I gave at a recent Schiller Institute conference. Let me begin with 2 1998 quotes from Lyndon LaRouche. He said, "Truth lies in the always radically revolutionary process by means of which valid new principles are generated, new principles which take into account the contradictions inhering in the previously proposed hypothesis. Reality lies in that higher authority which exists above any one hypothesis, which exists in the ordering of a valid succession of hypotheses. The legitimacy of science lies not in having the answer to everything at present. The legitimacy of science lies in being a path towards an increasingly less imperfect understanding of our universe, and we'll never be done." So the goal then of refining scientific inquiry has to be an improvement in the method by which discoveries are produced. And this is something that Lyndon LaRouche fought for over his career. He co-founded the Fusion Energy Foundation in 1974 to advance the needed scientific breakthrough that he considered to hold the most potential to fundamentally transform our physical economy and culture, namely the commercial use of nuclear fusion. In 1983, Ronald Reagan announced a policy which LaRouche had proposed, and for which he served as the back channel with the Soviet Union. This was the Strategic Defense Initiative, which called for U.S.-Soviet cooperation in developing anti-missile technologies based on new principles, such as particle beams and lasers, providing transformative economic spin-offs along the way. This was also an economic program. His 1988 presidential campaign produced a beautiful video, "The Woman on Mars," which we saw a clip of in the beginning of this panel, on the potentials for space exploration and space science to catalyze huge growth economically, scientifically, and culturally. Even while looking upward towards the heavens, looking forward towards fusion, LaRouche often criticized the practice of science itself, and he situated his views on present-day controversies in a rich history of science. When LaRouche was recruiting young people en masse during the disastrous George W. Bush presidency and the Iraq War, and especially also following 9/11. That was pivotal. LaRouche insisted that his recruits develop an educational process to ensure, most fundamentally, that they knew what it meant to really know something, to make or remake a discovery of a principle. The guiding theme for that educational process was Lyndon LaRouche's view of human creativity from the standpoint of history's greatest scientific geniuses and their discoveries. To this end, he laid out what he called a narrow path of discoveries that were crucial to understanding that valid succession of hypotheses, the process of science itself. So let's take a tour of this narrow path. We'll have 6 stops on our tour, and this is a preview of a class series that is coming later this summer that you can participate in. First is Socrates and Plato. This is Socrates. We see him at the time of his death in 399 BCE. He is about to drink the hemlock, the poison, the death sentence imposed on him by a jury in Athens. This prosecution was meant to rid the Athenian elite of one of its greatest critics. What made him a threat? We learned part of the answer to that earlier today with Mike Campbell and his discussion of Plato's cave. The individuals imagined to be stuck in the cave, seeing not real objects, but only projections on an irregular wall of objects passed in front of a flickering fire. You'd say, how could anybody possibly come to understand the real universe if that's all they're able to see? But that's the reality we live in. The cave wall. Think of that like our sensorium, both our natural off-the-shelf sensorium, our 5 senses, and our extended sensorium. Our eyes can't see infrared light, but if you get the right goggles, you effectively do have infrared vision. You have an expanded sensorium. When a scientist is measuring a magnetic field, an electric charge, so forth, we have this extended sensorium grown technologically. But no matter how good that sensorium becomes, it is always imperfect, not just by being incomplete, but by being misleading. The question to us is, how do we find and test our hypotheses of what is causing the outcomes that we perceive? Let's talk about Kepler for a moment. And this is easy, as we heard some wonderful presentations on this in the last panel. You have probably met, or I've certainly met, people who think that the Earth stays put, people who think the Earth is flat, in fact, and doesn't move, and they think the sun moves around it every day. I heard a few laughs. That's very disrespectful. The question is, how do you know that the sun isn't moving around the Earth? Or do you know that the sun isn't moving around the Earth? Okay, so maybe think about that. How do you know that? Try testing it out. Try testing it out with somebody who thinks it's not true. See if it's compelling or not. Now, the thing is that most people basically don't know whether that's true or not. Copernicus gets the credit for saying that the sun is at the center and the Earth moves around it, but as we heard earlier, Kepler made the sun a different kind of center. It wasn't at the center, like just it happened to be sitting there and these planets are going around and it's watching them. The sun was the reason that they were moving. Totally new approach to science. In fact, that's, I think Adrian put it, he said that Kepler abandoned geometric modeling altogether in favor of physics. His main book on this, The New Astronomy, why is it called The New Astronomy? Now, the full title of that book gives the answer. He says that it's a new astronomy based on physical causes. New era of knowledge. This made him the first modern scientist, according to LaRouche, who took teams of young people in his movement to work intensively on Kepler, primary sources, Kepler himself, to share it with the world. by what were then the latest technologies for animating and teaching, including interactive flash animations. This afternoon, we saw one of those ancient relics, and we also saw some new ones to help make Kepler's discovery understandable. In 2009, the 400th anniversary of the publication of that book, I had the honor of representing the LaRouche movement in Prague at the celebration there to commemorate this. You see me with my friend Kepler there. And on the right, there's the Kepler Museum, which had a grand opening in conjunction with this conference. In that museum, they had animations demonstrating Kepler's equivalence of hypotheses and other things, the LaRouche movement animations. Now, the next topic, I'm very glad, is something that Professor Happer already started to get into, which is it addresses the question of whether the universe has intention. Is intention a scientifically useful concept? So this underappreciated French genius, Pierre de Fermat, proved the scientific value of intention. When he read the overhyped René Descartes' stupid book on light, Fermat knew something was wrong. I'll just show one picture from Descartes to give you a hint why. That's a real drawing from Descartes' book. It's got a guy playing tennis, and he explained light based on balls bouncing off of various things. It was ridiculous. Fermat made his own hypothesis that among all the different paths light might take between any 2 points, the only path it takes is the one that gets it to its destination in the least time. So here you see an example, air above, water below, and in yellow you see a variety of different paths that light might take. You can see the little orange arrows at the end. That's like if they were all on a race and you took a photo finish at the end, you can see that the dark brown path won. It got there the quickest. And that is what light does. And as I'd mentioned earlier, Fermat might not have been the first person to think of this, but he was one of the only people alive who could actually see whether it was right, who could turn that idea into an angle and test it. So, is Fermat right? Can light have a goal? Does the universe operate by intention? Today, the answer is definitely yes. Professor Happer said that the universal principle of least action, or of minimal action, is the most fundamental law in physics. And this came from Fermat. I'm very grateful that I had the opportunity to work on a Fermat project that LaRouche commissioned, which resulted 15 years later in the first English publication of his work on light and his general method of maxima and minima. Thank you. Here I am with it at Fermat's birthplace in France. There were some copies outside. They're sold out. You can get them on Amazon. Okay, step 4 on our narrow path. Gottfried Leibniz. Gottfried Leibniz was Lyndon LaRouche's favorite philosopher, going back to when he was a teenager. You know, he was at home, he was reading the books on the shelf, and he really liked Leibniz. Now, Leibniz is an amazing man. He was able, by beginning from the premise of God's perfect wisdom, to demonstrate that absolute space and time were an impossibility. He had a dispute about this with Newton, or one of Newton's top surrogates, where the Newtonians said, God is all-powerful. He could have put the universe over here. He could have put it over here. Why did he put it here? Because he's God. Leibniz said, God is not just infinitely powerful, he's infinitely wise and good. Why would he do something without a good reason? Leibniz concluded the idea that the space existed independent prior to the things in it, that was the problem. This is 200 years, more than 200 years before Einstein's relativity, and Leibniz had it. In fact, to hit Descartes again, Descartes wrote also he wrote a lot of bad things. His laws of physics are terrible. He wrote a book, a paper about how balls colliding into each other, how they'd bounce off and so forth. Every single thing that he wrote in that book was wrong, with one exception. Two equal balls at the same speed will bounce off of each other at the same speed. Everything else, wrong. And Leibniz said that there was a more general principle that would help to determine whether a physical law could be valid. And that was, if you look at it from a changing point of view, if you transform the coordinate system, is it still valid? This is exactly what Einstein did. So, Leibniz is an amazing man. Now, in this session of the class series, what we're going to be focusing on is how Leibniz developed one of mankind's most important tools for understanding the world, the infinitesimal calculus. Leibniz worked out a way to understand the world as an unfolding of dynamic causes. This is the tool that Kepler called for when he had a changing principle and no way to say exactly where the planet would be. It's called Kepler's problem. Leibniz allowed us to understand the measurable result of a process in terms of an unfolding from its cause, where the cause is primary. His discovery had an impact on science like the development of steam power for manufacturing, completely opened up an expanded terrain of possibility. Fifth step, Carl Gauss. You may have heard of certain numbers in math class that got a funny name. Let me pose this question here. So this says x squared is 9. X times x, something we don't know what it is, and if we multiply it by itself, we get 9. What's the answer? Shout it out. 3. Any other answers? -3. Any other answers? Okay, so we had 2 answers there. How about this one? What's the answer? What times itself is -1? Okay, somebody said I, so I'm just going to have to ask a follow-up question. What is that? The square root of yeah, that's what this says. What's the thing that if you square it, you get -1? Imaginary numbers. You say, okay, you slander. You call it an imaginary number. Well, mathematicians admitted defeat by using this symbol. They said, we don't know what this is, but it's something that if you multiplied it by itself, it would be -1, even though that doesn't really exist. This symbol means we don't know what this is, okay? So Gauss, he said that this was slander. These numbers deserved full civil rights, he said, as the expanded domain of complex numbers. These complex numbers are akin to the reality casting the shadows on the wall of the cave, the reality casting the shadows on our sensorium, the real world. As a young man, Gauss used his understanding of the complex domain, rather than its mathematical symbolism, to prove in 1799 the fundamental theorem of algebra. The importance of this is that he showed in the process that most of the leading mathematicians were wrong in their approach. He was 22, and he was taking on the greatest mathematicians of his day, and he was right. He showed that you can know something not only by describing its appearance, but by knowing what it does, like a transitive verb. Most fundamentally, Gauss addressed in a concise, beautiful, and polemical way, it's really a drama, the subsuming pivotal question of what is the nature of human knowledge. LaRouche explained the importance of this paper. He said that on this account, epistemology, it was the relevant specific virtue of that 1799 Gauss piece which had prompted me to situate it as the cornerstone of the initial educational program of the youth movement. And step 6, AI. So on what technologies and techniques is the advancement of what is called AI, or if you'll allow me, machine learning, a little more neutral, what is the advancement in this field based on? Is there unlimited progress possible in this field? Will ChatGPT version 9 exceed the creativity of America, of the world's greatest, of history's greatest geniuses? Even before that, we're fast approaching an era where students write essays with Grok, which overwhelmed teachers grade with ChatGPT. So we have computers talking to each other. Now, the issue with these things, with these large language models, which I'm sure you know if you've used them much, is that they make errors all the time. They make up books that were never written, they cite data they invented, they send you to web pages that don't exist, they make illogical claims with great self-assuredness. So it thinks it's right. Allow me to anthropomorphize a bit. The question is it? Now, how are you going to answer that? The only way you know if it's right is if you know whether what it said is right. You need to know. You can't outsource knowledge. And you don't need AI for this. You can't outsource knowledge to experts, to received opinion, to common sense. It's up to you. You got to take responsibility for what you think. So the billions upon billions of parameters used by today's large language models to make new strings of text that look like answers to something that looks like your question, the parallel, and it was brought up in the Q&A last session, that this is the same kind of thing that Kepler's doing. Billions and billions and billions of parameters in the latest version of ChatGPT. What do those parameters mean? They mean there's no answer for that. It doesn't mean anything that we can truly say, except somehow it seems to work. Compare that or contrast that with the human experience of discovery and communication of a discovery. Is this an addition of more and more parameters? Is it the uncovering of a new simplicity? As we add more and more sides, do we reach a circle? In a certain way, according to Leibniz, yes. It's a very special kind of circle. In another respect, you'd say no. This polygon is getting more and more and more complex, but a circle is a very simple idea, isn't it? A very simple idea. So the Schiller Institute offers many ways to engage. Okay, that'll play again. We have economic, we got social, we got political initiatives, we have community choruses. In fact, in panel 2, we all had the opportunity to sing. And this summer, we are going to have an opportunity to engage in science from the inside. This is the registration link for that. As we look to fusion, as we look to the moon, to Mars, to the stars, let's take the time to be effective in collectively refreshing the human understanding of how we got here today. By what path of discoveries? What fresh thinking about galaxy rotation, quantum phenomena, spin-polarized fusion, immunology could come from people raised in a culture of choral singing and with an intimate consciousness of that scientific patrimony that belongs to all members of our beautiful human species. I hope to see many of you at the class series later this summer. Thank you.